And now it is my great pleasure to welcome my friend and colleague Giacomo Parrinello to Ohio Wesleyan's campus. Giacomo is currently a Marie Curie Fellow, which is a fellowship program sponsored by the European Union. And he's been for about a year and a half now at Louisiana State University down in New Orleans, working on both his research project that he's going to talk to you about tonight and teaching environmental history courses. After this summer, when his 2 years at LSU are up, he's headed to the Institute of Social Ecology in Vienna to continue to develop his interests in bridging historical research and geographical information technology and geography. He is also, as we speak, well, not as we speak, but today and tomorrow, frantically working on the copy edits for his first full-length book, which is called Fault Lines: Earthquakes and Urbanism in Modern Italy. And it's that project that he was working on when we met, when we were both fellows at the Rachel Carson Center in Munich. And we, in fact, bonded over our mutual love of gigantic natural disasters. But out of this, a real sort of collaboration and interest in each other's work on rivers also developed. And so I'm very excited to be able to let you guys see his really important interdisciplinary project. And he's one of a number of younger scholars who are actively working on bridging the disciplinary divides between what people think historians do and what people think geographers do. So he's working on an interdisciplinary project that combines environmental history of technology, urban theory, and geographic practice and theory to look at the history of the Po River. So I will let him explain more about that.
Good night, good evening actually, and well, let's see, first of all, if we can set this up. Yes, great. So thank you, Helen, for the introduction. Where are you? I don't see you anymore. Oh, here you go. Thanks to the Sagan National Colloquium, and thanks to Ohio Wesleyan University for inviting me. Thanks to the staff who's working to make all of this possible. And of course, thanks to all of you for being here. I hope to keep up with the very high standards that have been set by those who preceded me on this stage. I have thought a good deal about what I was going to tell you tonight. What part of my research project, from which angle. I ultimately decided I was going to start with me, with what I do. And so I had to ask to myself this very hard question, what do I do? And after some thoughts, I came up with this answer. Tracing water. I'm tracing water in past times and past spaces by looking at the uses that humans have made of it. I have two goals today. My first goal is to explain what I mean by tracing water and how do I do that. As we are going to see, this entails largely the use of visualization methods. Do you hear me even if I move around? It's okay? Good. The use of visualization methods and tools largely revolving around cartography and historical GIS, meaning Geographic Information System. My second goal is to tell you the particular story about water's past that I'm trying to write, or better, to visualize. The history of the Po River Valley. This is a fascinating story of water flows, humans, and their entangled history. A story that can put into perspective, I think, the challenges that we are facing today, the use and conservation of our precious water resources, So, while I will show you what do I mean by visualizing water's path, I will ask you to follow me on a journey along the course of this river and the water that flows into and out of it. Let me first begin by telling you how and why I decided to trace water. When I started this project more than 2 years ago, I knew a few things about the Po River Valley. I'm not originally from there, but I've lived in that area for a while. So I certainly knew where it was. And I also knew well that the Po River is the longest and largest river in Italy. I knew that it flows across the Pianura Padana, which is the largest alluvial plain in the country. And I knew that it's bordered by the Alps, this mountain range that you can even see here in the picture, and on the south side by a smaller but not less important mountain range, which is the Apennines. And I knew that its watershed covers most of northern Italy, including many alpine and Apennine streams and the great subalpine lakes, Lake Como, the Lake Garda, and the Lake Maggiore. Yeah. I also knew that this large hydrological system covers also one of the most densely urbanized, industrialized, and agriculturally developed region of the entire planet. This here in yellow is the urbanized surface as per 2001. And the big yellow area in the center is Milan and its hinterland. But of course, as you can see, there are urbanized areas almost everywhere. My question then was, how? What kind of relationship exists between this large and complex water system and this heavily urbanized and industrialized region? In the summer 2013, at the beginning of this project, I went to Parma. Why Parma? Parma is the location of all the most important agencies for the governance of the Po River and of its watershed. So basically, I was looking for historical sources and archives, but I also wanted to take the opportunity to interview some of the people who work there and who, of course, know a lot more than me about the Po River. And actually, one of the most stimulating and enlightened conversation I had was with the responsible of the forecasting service. This is the service, the ARPA, Hydro, Weather, Climate, roughly. The service is the terminal of a basin-wide network of monitoring stations which transmits data in real time about precipitation, water levels, discharge, and so forth. This data then treated via software to produce simulations about water availability and circulation across the basin. So basically, how much water is where and when? The most interesting part of the discussion, however, was not so much about the monitoring service in itself. It was rather on the problems associated with its functioning in an emergency situation. The guy with whom I spoke at this agency told me that knowing how much water will be flowing where and when does not necessarily translate into effective solutions. To illustrate that point, he mentioned a drought episode which had occurred the previous year in the summer 2012. He said that they could have used the water of the lakes, and he meant by that the subalpine lakes here, Maggiore, Como, and Garda. But since it was summer and thus tourist season, no one among local communities, administrators, and business person wanted to harm the picturesque landscapes of the lakes, such as this one here in the Lake of Como, by lowering the water table. You know, there are a lot of wealthy, rich people who live there. Among them also George Clooney, who's a celebrity in Italy too, apparently. And, you know, people there are kind of proud of having him among his residents. Anyway, that hint of a story got me so curious. You could not believe that. I would have never made such a connection alone. The drought in the Po River and George Clooney? I don't know you, but yet once we look at the big picture, actually, it makes perfect sense. The drought of the summer 2012 brought about a significant lowering of the river discharge, which in turn produced a cascade of other effects. Navigation stopped almost completely. That was not a big deal since navigation is relatively marginal in the region's transportation system. Yet that was not the end of it. Agriculture was affected too, and this time with much more serious consequences. Farmers are the principal users of water in the Padana Plain, and the hot summer of the Pianura Padana is the season in which water is considered indispensable. So Coldiretti, the Association of Farmers, denounced the situation as impending disaster for the harvest of 2012 and claimed for state assistance. Energy production was the next in line. In 2006, 6 years later, another major drought had actually hindered energy production, bringing to a stop a hydroelectric plant in the course of the Po River and also to the reduction of production in a thermoelectrical one. That was a huge problem, especially with the peak in domestic consumption of energy during the summer, due largely to the use of air conditioning, because it was too hot. And so everyone was turning on their air conditioning systems. So for that reason, the energy producers who controls the reservoirs in the Apennines and the Alps didn't want to release water, because they said, we need that water because we're selling a lot of energy. So no way, we're not reducing the level of our reservoirs, easing the drought downstream, because we need that water. Then the lower discharge of the Po River also increased exponentially saltwater intrusion, meaning the quantity of salt water that makes its way into the river. This harmed not only irrigation, but also drinking water supply for many riverine cities by contaminating both surface and groundwater. And then there were the lakes and tourism, which apparently is a water-intensive business as much as agriculture and industry, hydroelectricity. A myriad of interests were affected or were about to be affected by water scarcity. So what was happening? Pretty obviously, in 2012, like in 2006, it had not been raining for a while. This is an alarming long-term trend. Summers in the Mediterranean are getting hotter, and especially drier and drier. Yet this is not so simple. One of the reasons why the Po River is such a big watercourse are the Alps. The mountaintops act like a sort of a natural reservoirs. of water under the form of snow and ice, which feed rivers when they need water most, meaning during the summer. Yet alpine glaciers are in a worrisome state. Reduced rainfall and increasing temperature are causing a steady retreat of glacial surface, which is now dramatically visible almost everywhere. This is one of the manifold effects of climate change. A long-term and global factor that makes episodes like the drought in 2006 and 12 a likely occurrence in the future. Is this the whole explanation? I don't think so. During the drought, the problem was not so much that there was no water at all. The problem was that there was not enough water for all those who needed it. And this is a big difference. This is what the employee of the forecasting service was trying to tell me with his story about the lakes. The same water is contended among myriad of users. The need of agriculture conflicted with the need of tourism in the lakes and the need of riverine communities with those of the energy industry. This makes a crisis like the drought so complicated and the task of finding solutions so daunting. This is what makes the future, our future, so challenging. Because there will still be water, but there will not be endless water for all. Not the same way we're used to. So we need to figure out new ways to share and manage these resources, ways that acknowledge for complexity. So here is my central question. How did we get here? How did we get to that point? Let me now explain how I tried to answer that question. One thing that strikes me, fascinates me about the situation is how blurred the boundaries between what we consider natural and what we consider social are. What is, after all, that created the drought crisis? The rain, the rivers, the dams, air conditioning, the economy of tourism, irrigation-intensive agriculture. And why is it so complicated to manage? Because it entails competition for the same flows by a number of different users, and also because the same flows make possible a number of different activities without ceasing to be part of a natural hydrology. In the valley, technology, society, and water are part of the same system. The Po River Valley is what my colleagues in Vienna, Verena Winivarter and Martin Schmidt, call a socio-natural site. A site where the social and the natural blend almost indistinguishably. When you look at a particular site as socio-natural, it does not matter that much if it was more or less natural before, or if it should become more natural again. Those are certainly important questions, but it's a shift in perspective here. In a sense, it's like what matters is that is both natural and, if humans are there, social at the same time. So my point here is not to demonstrate that the flows of water are now less natural than before. My point is rather to understand the specific, particular blend of social and natural that we see today in the Po River Valley and its water flows. As every historian, I have the presumption to say that to understand the present, we need to look back. We need to trace the path that led us here. We need to incorporate time into the analysis. This is why I'm following changes in water uses over time, looking at their impact on water circulation. When and why the multiple uses that we have seen acting together in the drought crisis came to overlap this way. I decided to start as far back as the mid-19th century. There are good reasons on my side, I think. All water uses that are preeminent in today's Po Valley started to emerge from the mid-19th century onward. Large-scale irrigation, urban sanitation, hydroelectricity. This is not enough, however. Space, indeed, matters as much as time, especially for the kind of questions I'm asking. Water flows have an intrinsic geographical dimension. They have a direction. They occupy space. They have a location. So it's not only about when and why. It is also about where and how. Their position, direction, size create spatial relationship between distant places and apparently unrelated activities such as sightseeing in the Lake Como and the rice farmers in the Delta. The point thus is not only to look at change in time, but to think change geographically. What kind of connections have been established via water flows? This is when visualization comes in. Viewing spatial and temporal patterns of water uses become essential to understand their transformation. Visualization means different things for different people. In my case, visualization means largely geo-visualization through GIS, Geographic Information Systems, software that allow for storage and manipulation and visualization a large amount of data. A growing number of historians like me are recurring now to GIS to deal with complex historical processes of which they seek to integrate the spatial component. Studies of visualization, of course, crosses a number of different disciplines, almost every discipline. Neurosciences, psychology, the arts, graphic designs, and so forth. The bedrock of all these different approaches, however, is the conviction that visualization is a powerful way of knowing. The forms of knowledge stimulated and produced via visualization are of a different order than those stimulated and produced by text. Maps are among the best example of the power of visualization. I would need a long amount of text, much longer than this, to describe the borders of the Po River, explain the position and hydrological relationship between the main river and its tributaries, the mountains and the plain, and blah, blah, blah. In the end, I'm not sure that you will have a clearer idea than when you enter this room. If, however, I show you this, your understanding is immediately clearer. And most probably, I bet, more durable. You will probably remember more this than the text that I showed you before. Here, you see the river, you see the tributaries, you see the mountain and the plain, and you understand their relationship. Yet, there is nothing obvious in this effect, certainly nothing natural. Creating a visual representation does not mimic reality. It recreates a new reality through symbols, showing something but also excluding something else. There are no cities in this view. Yet, the same creative and, in a sense, also dangerous power of geovisualization and maps entails also great potential. It allows analyzing data from different perspectives than text. And it allows understanding clearly things that may otherwise more difficult to grasp or that may remain on the outskirts of understanding. This is the use I'm doing of geovisualization. I use it as a tool to organize and analyze my data, and as a tool to develop my questions about socio-natural site in time and space, and the history of geography of water flows. So for the remainder of this talk, I would like to show you some of the ways this applies to my research. and some of the most salient part of my historical GIS project, while telling you more stories about water flows in the Po Valley, this time, unlike the story of the drought, from the far past. I would like to begin this section, actually, with a story that is from an older period than the one on which I'm focusing most, which, as I said, is the last 150 years, right? This older story, however, will help me make a very important point here. One of the things that I found the most fascinating about the Po Valley is that it challenges every concept of natural landscapes. The waterscape of the valley has changed so many times over the ages that to find an original is almost impossible. It's even pointless, probably. Large-scale modification of the flows began at least with the ancient Romans, if not earlier. Romans were renowned constructor of canals and drainage ditches. The hydrology of the valley changed again in the Middle Ages, and again in the early modern, and then again in the modern time, under the combined action of humans and water. Maps can tell some of the stories in a very powerful way. Take this map, for instance. This is a map of the Duchy of Ferrara, one of the many small states in which Italy was divided until the national unification in 1861. Ferrara, for how small it might seem, especially in this map here, was a powerful city in the Middle Ages. And much of that power depended on its position. It lay indeed between the two main branches of the Po River, in the Delta region. It was a strategic outpost for navigation between the Adriatic Sea and the Pianura Padana. And you have to think that in the Middle Ages, navigation was a big thing. It was perhaps the most important means of transportation in that region, unlike today. That map was designed by a renowned, at the time, Italian polymath. His name was Giovanni Antonio Maggini. He has a funny story of rivalry against Galileo, because this guy actually was chosen to occupy the chair in mathematics instead of Galileo at the University of Bologna. But this guy didn't believe that the Earth revolved around the sun. So I think that says a lot about why he's not remembered as an astronomer, but is remembered as a cartographer. And indeed, he devoted the last 20 years of his life and career to a gigantic, crazy, visionary cartographic project covering the whole Italy, which he never saw completed, and which cost him basically his entire fortune. This one is one of the sheets that he never completed. It was his son Fabio that published it. The map is amazingly rich in information. It would take a whole talk just to describe this map. I would like just to show you, as an example, one feature here. You see here, bonificazione, that means reclamation. And those lines here are drainage ditches, drainage canals actually, more appropriately. The reclamation of that area had been undertaken 1 century before, in the 1500s, by the Dukes of Ferrara to create new agricultural land. This map keeps track of all that, and also about the extent of land which was not included into the reclamation works, which is, if I can, here. The moment when the map was being drawn was particularly charged in consequences for water circulation in this region. Yet the most valuable piece of information about this change is missing from this map, actually. See here, this squared gulf here, which I'm pointing with the arrow, this is called Sacca di Goro. This is the sea. This is the Adriatic Sea, right? And here you have a little branch of the Po River called the Po di Scirocco. and this small island created by sediments of the Po River. Well, as the map was being designed, water would not flow in that direction anymore. Let's look at another map, this one drawn more than 1 century later. The author of this one was called Paolo Bartolomeo Clarici. He spent the first part of his life as a merchant in Padua, near Venice, and at the age of 53, actually, he became a priest and devoted the rest of his life to botany, painting, and cartography, which is a good example of how there's no limit of age to find your own true vocation. He was certainly a talented cartographer. I think this map is gorgeous, it's beautiful. He drew that, it was a commission. It was commissioned by the Doge of the most serene Republic of Venice, Giovanni Corner, who wanted to have an updated version of the map that Maggini had drawn 1 century earlier. This map, as I said, I think it's really gorgeous and once again rich in details, and I cannot spend my whole talk discussing that. But the point here is that this map tells us in full detail the story that was missing from the previous one. You see this grayish line here? This is the squared gulf I just showed you before, the Sacca di Goro. Yet, there's no sea here. This is all land. New land. And also, here, this is a flow of water that was not there before. This was a canal. A diversion canal built by the Republic of Venice more than 1 century earlier, when the other map was being drawn. Venice is just a few miles north, here. Just north of the delta of the Po River. And the lagoon just starts right after the delta. So, why to build a canal here? Well, actually to protect Venice. The water of the Po River carried a lot of sediments and sand, and so it menaced to fill the lagoon, and so undermine the very reason of the power of Venice, is being on water, its relationship with water. So Venice decided to undertake the construction of this massive diversion canal that I just pointed you, to carry much of the flow of the Po River away from the lagoon and southwards. And in addition, and this was perhaps a hidden motive for this diversion, it would also damage Ferrara, undermining the hydrology on which the city had prospered. And indeed, 1 century later, when this map was being drawn, there was no more water from the Po River reaching the branch of Ferrara. Venice did succeed on all fronts, and even more than expected, actually. The Taglio di Porto Viro, that was the name of the diversion, literally cut of Port Viro, was one of the most significant events in the history of the Po River Delta, and has continued to produce effects over 4 centuries. After the diversion, the morphology of the delta has continued to evolve in a new direction set forth by the diversion of Venice. And land, now in the blue here, has gained even more space. This was where land was in the 1700s, and this is where land is now. This story happened before the period on which I'm focusing the most, yet it teaches a very important lesson, I think. There is no origins to go back to. And all the transformations that began in the mid-19th century occurred on a landscape, or better, waterscape, which was already significantly modified by the action of generations of men and women over 1,000 and 1,000 years. After 1860, however, things started to change fast faster than before, and widely. The country was the place where those changes were most visible at first, and irrigation was the prime mover. Irrigation nowadays uses 2/3 of the surface water of the watershed and feed one of the richest agribusiness of the European Union. Rice, corn, sugar, livestock, you name it. Look at this map, and look at this map now. In green, all canals, all artificial. The density of canals in the lower plain largely outweigh natural watercourses. Even if we simplify this view and show only the canals which are longer than 20 kilometers, you see that there's a lot of them. Many of these canals existed since the Middle Ages. I'm sorry about that. Decided to, here we are. This arrow here on the left side of the map keeps track of time. If we go back in time to 1850, we see that canals were already a big thing by then. To be clear, these are not all the canals that existed by 1850s. Only those which I was able to date with certainty so far. More probably, other will be added to this picture as soon as I will be able to date precisely more canals. They were used originally for many purposes: navigation, drainage, military defense, even construction, like in the case of the Milan Navigli, which were used to bring stones to build the beautiful Gothic cathedral in the center of Milan. After 1860, however, a new wave of canal building would dwarf all previous accomplishments. Italy had just become a new nation by then, and the elite of the new country was seeking opportunities to make money. And water was a good opportunity to make money. Irrigation and abundant water supply can increase enormously profitability of existing farmland, or can even create new farmland by bringing water where there's none. The first big canal to be completed was the Cavour Canal. At that time, it was one of the largest and longest diversions in Europe, later followed by a network of small distributors. Later was the turn of the Villoresi Canal and its related network, followed by a few other canals in the following decades. And then in the 20th century, other canals came. The longest and the biggest one is still the Emiliano-Romagnolo Canal, which was built after World War II. The canals built after 1860 are the longest, still today, of the entire region. And this alone makes them exceptionally significant. Especially the first two here. They bring a lot of water very far away from where they take it. They almost create a parallel river here, as much as this one, for sure. And in addition, they also had an impact on the existing canals. They intersected horizontally the network of the existing one, creating a new geography of flows of water. So if we reinstate the view of all the existing canals today, we'll still see how important those new ones are. To produce this visualization here, written sources are often essential. The geographical data about the canals are pretty easy to obtain. We know where they are. What is much trickier is to add time dimension. When was that canal operational? This is when written sources become crucial. Archival records, governmental documents, geographical descriptions from various ages. These are all often only the only way to know the where and when, the when and why part of it. The same kind of reliance on written sources for geovisualization has been proven crucial in adding a new layer to the space and time of water uses in the Po Valley, the city. As much as most European and North American cities before, starting from the late decades of the 19th century, 1880s or so, even Italian cities felt the need to undertake the construction of new waterworks to improve the health of its inhabitants. Water intakes, aqueducts, sewages. This process, sometimes known as urban sanitation, was not only limited to big cities, in fact. It was also something which involved small country towns as well. These are the cities, in this view, and towns that had an aqueduct by the year shown in the arrow. This is in 1900, 20, and 40. It was a significant phenomenon and with a wide distribution, and contributed significantly to rearrangement of water flows in the Po Valley. Even in that case, we are working with written sources. And the job is pretty long and tedious, actually, and I'm really grateful to the people who are helping me with that. Otherwise, I would not see the end of it. But it's a lot of work, but it's rewarding. You have to spend your days reading stuff like this and copying information into spreadsheet, which is terrible. I would not recommend that to anyone. But then the result of that tedious work is that you can see some cool stuff, I think. Let's now take a look at the overall situation in 1940, by the end of the sequence I showed you before. This in green here are the cities and towns that used surface water, okay, to drink and other urban uses. They had access to surface water. And those here are the towns and cities that use groundwater. There is a pattern here, clearly. This pattern is at first explained by the hydrogeology, probably, of the Po River. In the mountain region, water is available through multiple streams, flowing directly from the mountaintops, while in the lower plain, the water flowing down the mountains infiltrates the permeable soil and feed groundwater. If we look closely to this map, however, we can see a notable exception. You see here this cluster of green dots, meaning they had access to surface water, surrounded by all orange and red dots, groundwater. Why? It turns out that if we zoom in, we see that this region corresponds to, this cluster of green dots corresponds to the region called Montferrat. Montferrat is a beautiful hilly region devoted to viticulture. And it turns out that they had neither abundant surface water nor groundwater. So in the early 20th century, in the wake of those sanitation policies that brought about aqueducts almost everywhere, as I showed in the series there, basically they decided to find water somewhere, and so built a big diversion. Once again, take water from a place and bring it far away. The project was delayed until the 20s and then completed in the 30s. And if we superimpose to the view of this green dots here, the map of the aqueducts, well, it all makes sense. The green dots are all cities and towns that were served by the aqueducts, which take water from the Dora Baltea River, which was a tributary of the Po River. It was a significant, again, rearrangement of flow. It was water taken from one place and brought somewhere else, creating new geographies, new connections with the Dora Baltea to a region which didn't know such an abundance of water before. Changes in rural and urban uses of water, like this that I illustrate, have largely contributed to creating new flows of water. Flows to carry water from distant places, or flows to bring water from the underground up to the surface, and then in sinks and toilets and houses and lives of people. Yet perhaps the most significant reshaping of water flows was due to the introduction and diffusion of hydroelectricity. And this is going to be the last of the uses which I will present you today. The use of water to produce energy was hardly a novelty in the Po River. Once again, we have a long history, even of that. In a census of what they were called industrial uses of water, between 1880s and 1890s, they surveyed something like 10,000 working water wheels. 10,000 in the entire Po Valley. It's a huge number. Cotton mills, sawmills, foundries. There were even floating mills along the course of the Po River. Starting from the 1880s, however, hydroelectricity will change everything. Let's take a look at the spatial temporal pattern here. Once again, the arrow keeps track of time. And the green dots are existing power plants, and the yellow dots are the new ones. 27, 37, 47, 58, and 70. Almost everywhere. Almost every tributary has a power plant, except for the Po River. To get this kind of visualization, again, tedious work, but rewarding. And in this case, it's all about a register. Register produced by the state, who was the owner of all the water in Italy, the most important water courses, who decided, well, I'm going to keep track of all the water I'm allowing others to use. And so we have information on the power plant, the owner of the power plant, the kilowatt per hour, the name of the river course. Yet we don't know where the power plant is, which is tricky. You need to cross-match a lot of other different sources to understand where the power plant was located. And you had to do that for each one of the small dots that I showed you before. To make things more complicated, most of those power plants do not exist anymore. Sometimes there are even no more traces on the landscape. They were created in 1910, and 30 years later they were too small, so they were just teared down. And they built something else in the place. So sometimes you can get a good approximation of the location by using several kind of other related information. You have to do a sort of a work of interpretation, or the work of a detective if you want. You have really to find traces here and there. Sometimes, however, the location is approximate. And this is one of the most enduring obstacles for geovisualization and historical GIS. You have to deal with uncertainty, both temporal and spatial. When you don't know exactly a place or a year, in a text you can just add a lot of clumsy words and it will work out. With GIS, you need to fix a precise point. You have to attribute a year, and sometimes we do that, but we're not that sure about what we're doing. Yet it's worth the try. What about water flows then, with this kind of information, with this kind of works? Well, hydroelectricity entailed a larger rearrangement, once again, of water flow on a large scale. The first level is just incorporation of flows into turbines, not necessarily a dam, okay? You just take the flow of a river and you bring it into a power plant, it powers the turbine, and then it goes back to the source. This dots here identify the power plants, and they are sized according to the quantity of flow that was incorporated into the power plant. And again, a sequence 37, 47, 58, and 70. Again, there was certainly an increase. Yet this kind of use is substantially different from irrigation. Irrigation, this is a very important thing, takes water from a place and brings it somewhere else. And that water will not go back immediately to the same place. There will be a whole new water cycle before that, the point of origins gets water again. Well, this kind of use, on the contrary, is not that significant from a spatial point of view, because it just gives back the water to the source almost immediately. And indeed, this is why this kind of use was compatible with irrigation. Sometimes power plants were actually built into irrigation canal, and some of them are still active, or others are being reactivated, following a policy of small-scale plant to find new sustainable sources of energy. This is not the case with hydroelectric dams. Damming has a major effects on water flows, not comparable to that. This map does not show plants. It's not showing power plants. It's just showing reservoirs. Reservoirs are a different thing. One reservoir can feed several different power plants. 1915, 27, 37, 47 after the war, 58 the beginning of the economic boom of Italy, 70 the higher point, and then Italy will switch to other source of energy. But not just that. They will not just switch to other source of energy by chance. They will switch to other source of energy because they basically had taken everything they can. There was no much more that you could do here. The size represents the quantity of water retained. Almost every tributary has been dammed. And this has a major impact. It changed the quantity and rhythm of the flow. Almost everywhere, with immense consequences downstream. All users downstream are affected by this. By so doing, hydroelectricity and damming in particular created new interdependencies, new interconnections, influencing with a reservoir here what was happening here, and creating many more new conflicts between users of water. In my mind, this is just the beginning. The next step is the full integration of those different views to see what kind of patterns will emerge by cross-matching the maps of irrigation with the maps of power plants and the maps of energy, and the maps, of aqueducts and groundwater, and see where it might be worth to do more fine-tuned investigation. For instance, one thing that is emerging is that the same region where groundwater are concentrated is also the region where most of irrigation happened, which leads me to believe that perhaps the reason why in that area the cities were recurring to groundwater and not surface water is because all the surface water was already taken for irrigation. And so it might be worthwhile to look more closely into those settlements in this region and see if there are some interesting stories that can shed light on this process. There is also much more to add to this picture, of course: drainage, reclamation, industrial pollution, but above all, one most important piece of the story: flood. Floods, aka water flowing where and when it is not expected, not wanted. The history of flooding would show, as much as drought, how much a natural hydrology is still at work, even in the most technological of the landscapes. But this would be an argument for a whole new talk. Let me just conclude with a few remarks on what we saw, if it decided to lead me. So, first, sorry about that, just resuming the view. Here we are. First, I was saying, space-time. Incorporating both space and time. Oh, I have to accept this condition. Yeah, sure, wow. Incorporating both space and time in the analysis allows for better understanding of processes, in particular in this respect, water flows, transformation of water uses, and impact at the scale of the entire region. A geovisualization is a good way to deal with that, with large-scale inquiry into geographical distribution, relationships, evolution through time. It has a great analytical potential, especially in environments which, like GIS, allows you to zoom in, zoom out, change what you want to see, overlap different views, modify the size and scale of what you see. It becomes, in other words, an analytical tool, and it can be used as a way to integrate space and time in the analysis of change. It does not exclude the traditional historical analysis. On the contrary, as I hope to have made clear, you need traditional historical analysis, first of all, to build the GIS and do that tedious work I was showing you before with those texts that you have to enter into a spreadsheet, and second of all, to make sense of what you find. Like in the case of the Montferrat Aqueduct. You see a pattern, but you cannot explain it that through GIS. You need to look into that, to go into the archives or libraries. So it's about a combination of historical analysis and this kind of instruments that we can, I think, elaborate compelling and effective way to analyze change in space and time. Second point, interdependency. Each of the various aspects of the modernization in the Po Valley over the last 100 years has created new geographies of flows. Agriculture, urban sanitation, industry and energy. These geographies, although, didn't like me here, although created by separated process, have created a whole new host of interconnections. Interdependencies that were not in place the same way as before. This is because, although they evolved separately, sometimes even independently, irrigation, hydroelectricity, towns pumping groundwater, they all share the same water system. What has happened, in my view, is the creation of a whole new scale. A scale in which it becomes possible for George Clooney and his villa on the Lake Como to be directly connected to the farmers in the Delta. In the end, and this is my third and final point, this interconnection and the problem it creates, the conflicts, the complication, especially in situations like the drought, as I showed you at the beginning of this talk, poses a problem of democracy. Who has the right to decide in a system where my decision affects not just my neighbor, affects all users of the system, even apparently distant one? This system, this complicated region of hydroelectricity and irrigation canals and aqueducts and groundwater, was not built with the idea of interconnection in mind. As for the present, thus, there are no effective decisional process to deal with that. There are no decisional process that acknowledge for interdependencies. And yet the lives and activities of all the millions of human beings and creatures of other species, those lives depend on that interdependency. Visualization and mapping, I think, can be of some help as an instrument for democratic decision. They can be a way to make knowledge available to the public and stimulate a debate, I hope, on the management of water resources in an open society. This is where I would like to go with this project. Not just making this knowledge available to scholars, but create instruments to make visualization of water uses through in space and time available to the public. Geovisualization can help make clear entanglements and their development through space and time. It can make clear how we all use the same water, and thus we all need to take care of it and decide about it all together. Thank you. Should I
Stay there.
stand at the
Yeah,
floor? Okay.
stay where you are. Thank you so much. I am actually really delighted to have a new word to add to our conversation in addition to interdisciplinarity. I think that this interdependence idea that Giacomo ended with is another sort of connection that we've seen across a lot of these talks. So thank you very much for that. We'll now open the floor to questions.
I don't bite.
Thank you for a great talk. I thought it was excellent. So I think you have some pretty clear lessons for geographers. As someone who does interdisciplinary work, and you're both sort of a geographer and a historian, the notion that there are no origins to go back to, the notion, even the category of natural social space, I mean, as a historian, you would sort of say, well, all natural space is social. Nature is a social construction. And so I presume that you kind of lecture your geographer friends about that, and you tell them not only that archival research is hard, but that a lot of their things need to be historicized, a lot of their ideas need to be historicized. This isn't a question, I'm sorry, I'm just underscoring a few of the things that you said.
Yeah, no.
It strikes me as a historian, though, that probably the most valuable thing for me of what all the things you said was that ultimately the Po River, environmental historians would say, obviously you would map it. Of course, maps give you visual aid, yes. But I would say, insofar as it is a system, and it's a system of power and power relations, the real lesson I think for historians here is that everything can be mapped. There's nothing that could not profitably be mapped and visually sort of be expressed. So I just wanted to thank you, for really hammering home on that point, and hopefully giving us all something to think about as far as how we can express data or narratives or whatever it is in the past.
Can I comment on that?
You can certainly comment. It wasn't a question.
Yeah, no, but I really like your comment. I just wanted to say something. Perhaps what you said about me lecturing my colleague geographer might be, to a certain extent, true to respect to the physical geographers. But, you know, cultural geographers and historical geographers know that lesson very well. But yeah, that's certainly important. And the other point, yes, that everything can be mapped. Absolutely yes, and it's being mapped by many colleagues. Many phenomena are being presently mapped, and it's a good way, as I said, is an analytical tool. It's not something that gives you answer. It's not that then you have the map and you have all said. It's just a way to see things differently, and it really makes a difference. More than one you can say, yeah, of course, maps. Yeah, historians have always used maps, by the way, historical maps, but GIS is also the way it can be transformed rapidly, which you cannot do with a traditional cartographic way. You know, you have to spend hours drawing one map. Well, in GIS, you can just click and have a whole new view of, and in 50 seconds, really, view all together, or zoom into a region and see other patterns. I showed only images of the entire watershed for the sake of clarity. But there are a lot of different patterns that you can see if you zoom in. And sometimes zooming in is a good way too. But I wanted to underscore interdependency, which emerges only at the scale of the entire watershed. And I think it's an important lesson for which I've learned as I try to explain. First of all, I've learned from the people who work in the meteorological service, actually. They explained that to me. I'm just trying to add the historical dimension. But they have it very clear, and it's frustrating for them. Because they know. They said, yeah, well, farmers are losing their crop, and there's water in the lakes. And the lakes now, they have some sort of a technological, they're natural lakes, okay? But they can be sort of opened to release the flow artificially. So they could have used the water of the lake. The only problem was the will of George Clooney.
So
I don't want to blame everything
all
on George Clooney.
One of the things that I stress a lot, especially in my ancient history class, and I see a lot of them sitting here in the audience, good job, is that maps aren't just fact, that maps are argument. And I think one of the things that's delightful about this is you've shown how we can make lots of different arguments with the same geographical map. But that implies then that you choose what to put on, but also what you choose to take off, and what you choose to not put on your map. And I was wondering if you could talk about that.
Sure. Well, as I said at some point, I mean, there's nothing natural in the kind of image that maps convey. First of all, I mean, we should be all amazed by the fact that if I show you an image with some lines and colors, no one here in this room has a doubt about what does it mean. We're not looking at the river. I think we're all clear about that. We're looking at a series of lines and colors, and yet it all makes sense for us. This already is amazing and is the product of centuries of visual education that have brought us to understand in a click what doesn't mean the patterns that are in the map. And this has an immense power effect in it. When I showed always in the section of visualization, you know, there was this map with to show the watershed and the rivers and the lakes and the mountains. There were no cities. And if you eliminate city from the view, well, you're making one argument and not another. You're looking at the water side of it, but reality is, of course, more complex. And this is a problem I'm dealing with also with my maps. I mean, I'm making arguments. I'm selecting features to make a point. But at the same time, is it possible to map everything? You know, once again, this is our view of mapping as something natural is so deeply inscribed in our history, in our cultural history, in our heritage, that we can't consider it as natural again. And yet, you know, the map that reproduces the world entirely is the world itself at the scale with all its details. So the point is, how do you use it? And this is why I want to use it and select the features that I think can make more clear the argument of interdependency, which I think is, of course, I'm taking position here. My position is that this issue of interdependencies is key to the future of this region. And so I want to show that. But just to conclude on that point, one of the most interesting possibility, not just of visualization or mapping in itself, but of geovisualization, is the possibility of create virtual environment in which the user itself choose which feature to identify. So the richest the database you build, the more possibilities there are for users to select their own features. And there are some interesting projects out there on that. You can choose what you want to select, what you want to see, and where. And this empowers the people, you know, empowers the users who decide what to see and what not.
All right, I think that we are all ingesting a whole bunch of visual imagery and visual literacy. I want to thank you very much for this presentation and for showing not only the relevance of mapping and visualization, but also the relevance of the past to this discussion of where we are now with water. So Thank you.
Thank you.